Another thing that we should talk about is power.
How much do I need to pay off the person that grades my test? 5?
Your car.
Yeah.
Okay, here it is. What other car do I have?
I need this. It's the
So when we talk about power,
That's good.
Yeah, so I
Steal
can't.
your dad's.
so power is the time rate of change of the energy. Okay.
Is it still under energy and
Yep.
work?
It's actually more like 5.
Power is the time rate of change of the energy.
So much.
What that means that if you have a system where the energy is changing, we can figure out the power. Does that make sense?
Yeah.
So let's take your car. Okay, let's take your car, and your car is going to go from, right? Let's say it goes from 0 to 60.
In 1.27.
Okay.
Yeah.
It's pretty impressive.
That's the sound.
So let's say your car goes from 0 to 60. Was there a change in energy here?
absolutely.
Right? Did the kinetic energy change?
Yes.
It did, right? So we could actually calculate, if we knew how much time it took, we could take the change in kinetic energy divided by the time and we get the power output of the car. Does that make sense? Now, in regular cars, we call this the horsepower, right? Right? In here, we don't use horsepower, we use watts, but those are interchangeable. One's a metric, one's a SI, one's an imperial unit.
Doesn't horsepower come from torque though by an equation?
Those two things are related. I do not know how.
Apparently, supposedly there's an equation that takes torque and creates it horsepower.
I am sure. Now, there's a theoretical horsepower, right? And then there's the actual like output given like the friction, the internal friction and the external friction. So it's work over time. Is that cool? So unit-wise, work is measured in joules and time is measured in seconds, true? That's watts. Cool? So if you can figure out the amount of work done, which is the change, in this case, the change in kinetic energy, we can figure out, and you know how much time it took, then we can figure that out. This is true for anything though, whether you're changing the gravitational potential energy or the spring energy or work done by friction. Any change in energy, if you can divide by the time, you can find out how much power output there was. Sound good?
In foreign countries, do they literally advertise cars as having a certain wattage instead of horsepower?
That I do not know.
That'd be funny.
Do they consider
Get your
horsepower is
new
pretty
Ford
Could
Mustang.
they, in theory, then,
700
like,
watts.
like a light bulb
2 watts.
advertise as horsepower?
Yes.
They could.
Sure.
How much
What
watts
it-
is
what it
that
costs?
horsepower?
Wait,
You know?
so when a light
If you could
bulb,
like have a light bulb advertised.
A light bulb has horsepower.
794 or something like that?
Yeah, horsepower.
People would be like,
like,
That's a lot of watts. That would be like.
well, I know what a
thousands
lot of
of
it
watts.
is in a boat. Mr. Paddock,
Yeah.
I have a question then,
Sure.
like just kind of off the beaten path. So, well, it's like not. So like when light bulbs are measured in watts, then like does that have to do with the power it can output over the amount of time it'll last? And that's how they get that value?
Yes and no. The way you said it, I think you have the right concept, but not the right wordage.
Okay.
So we talk about a couple different kind of light bulbs that we have now. Old school light bulbs are called incandescent bulbs. And they work by, there's an actual like filament here, it's a tungsten filament, and what happens is you pass electricity through it, it resists the flow of the electrons and gets real hot and real bright. Okay?
What they use to level.
So if you have a 60-watt bulb, what that means is that is the power. Like that's the power.
Yeah.
That means that it's giving off 60 joules of energy for every
1 second.
1 second of time that it's on.
Oh, okay.
An incandescent bulb gives off energy in two forms, right? It lights up and it heats up. Those are both forms of energy. Does that make sense?
So is the 60 joules simply the light, or is that light
Like the
and?
total.
It's the light and the heat.
That's why the ones
Okay.
that don't use.
That's
So-
why a larger wattage light bulb has more brightness.
That's right. So a brighter light bulb
Oh.
And that's why
100
LEDs are
watts.
so much better
Because they don't
in
make
fluorescence is because they don't make as much heat, so it all goes to the light.
So now we have, oh, that's not real. Now we have compact, you actually don't see, I don't even think you can get these anymore. They were really fashionable about 10 years ago. They were compact fluorescent bulbs. So
Oh, the
they would
circular
take
ones?
these fluorescent bulbs and they kind of shrunk the tube down and kind of like wrapped it around. Have you ever seen
Oh,
this?
I have.
Yeah.
I think my
Yeah,
basement
it's
still
like
has
it's like
one
an
or
old
two.
school.
Oh, you can't get them anymore.
No, you probably.
Because apparently, once they crack, they are really bad for you, and you have to like
Oh, those
leave your
ones?
room for like a
Oh, what the hell?
Are you
Oh, well, I
serious?
see.
Yeah, I have.
So they kind of wind around
Yeah.
like
I
this.
used to have one of those.
Yeah.
But it'll
Mine
say
didn't
something
look like
on the
it.
package. It says 30 watts or 13 watts equals 60 watts. I'm like, that is not good math. Okay, that is not good math.
Listen, man,
The 13 watts.
they need to go with the.
What it means is that this is a 13 watt bulb that's as bright as a 60 watt
Oh.
incandescent bulb. But it's only
So that's
13
way
watts
more.
because they don't heat up. So you're using so much less energy to get the same amount of light.
It's a great marketing scheme if everyone had a good brand.
16 watts.
We've switched to compact, or from compact fluorescent. Really, it's like LEDs now. There's a lot of
Pretty
LED
much
light.
only LEDs, yeah.
They last so long too.
They do, and that's good for everybody, right? Except for light bulb manufacturers.
Thank you.
They don't like. Okay, so get rid of these guys.
Out of curiosity.
Apparently there's a lot of collision between light bulbs.
Watts and joules over seconds. What would be the units for horsepower? Horses over seconds.
So, when they were doing horsepower, it was the feet.
4.
What was it? It was the amount that a pony could lift coal out of a well. So it was a distance and a weight. So it was foot-pounds.
So it's kind of like.
That's just-
And that's
Really,
really-
it just sounds like work, like, but with.
Is it torque
pushing
per
something
pounds in
across.
American?
Well, so here's the thing. When we talk about work and torque, okay? So this is an aside. So when we talk about work, work is a force and a distance, right? And I talk about torque, I'm also talking about a force and a distance,
'Cause
true?
They have the same units, don't they?
They do, but what's the difference here?
One's
Normally we
angular
put
and
one-
one's
So
linear.
this force and this distance, we want these in the same direction.
We don't
And this is
torque.
going to change the kinetic energy of an object.
The dot product.
But this force and this distance, actually it's this distance and this force, we want those to be perpendicular to one another because we want that to rotate an object.
Cross product.
So that's right, so this one, that's why this is the dot product. And this is the cross product. It matters the fact that it's D cross F, not for this discussion. What's happening?
The sky's really pretty.
Oh, yeah, the sun was
There's
really
not much
nice.
light.
And the moon,
Noise.
the moon, you can actually tell
light
based
too.
on the way the sun is at the angle, the moon is a,
We should look at the stars after.
do you not realize that?
It's a
It's a
waxing
waxing gibbous. I took a picture of it because it's.
So you noticed it
pictures.
after the fact.
But the problem is, I'm not looking forward to taking the pictures in, like, for the waiting ones, because that means I have to wake up at like, way earlier than I would really like to. Can I just skip those and look on my
But
phone?
the point is that this would be Newton meters, and ostensibly this would also be Newton meters. Right? You see how we could see that the units might be the same, but conceptually these are two very different ideas. Cool?
Yeah.
22 newton meters is 16.5 foot-pounds, just so you guys know.
Thanks, dude.
All right, one more thing.
I was actually wondering.
If I want to calculate the
I
power,
was too, that's why I looked it up.
again, we need a force and a distance, true? So in our most basic definition, if I look at an object, this is the force times the distance, I'm going to divide by the time. Okay? Do you notice here, though, I have a distance divided by a time?
That's velocity.
That's the velocity, right? So one way that we see the power is it's FV, where F is the force at any one moment and the V is the velocity at that moment, so you can get instantaneous power if you know instantaneous force and velocity. If you knew, let's say the force was constant and your object sped up, if you could also get the average velocity, you could also get the average power. Yes?
Two things. capital P is power and lowercase p is momentum.
That
right?
is true, yes.
And then, isn't these both vectors too?
Yeah, so look on the sheet, okay? If you look on the sheet, right below the hole punch,
They give you the vector form.
they do. So this is important. It's saying like, look, if you want to calculate the instantaneous power with FV, you got to realize that they're both vectors, so you should probably use the dot product.
Where is this at?
Right below the hole punch.
Oh, I was looking at the wrong one.
So what's the one above it, the,
So the power, it just says it's the change in energy divided by the change in
oh,
time.
because DE is the change.
But that's an instantaneous change, but we don't.
Care.
Like, you could take the derivative, but I don't think anyone ever cares.
Why did they put D instead of the delta?
So
Is
it,
it to represent a derivative?
it does, that's exactly what it does.
Off the side, probably, like, is it they're like off the side now?
Oh.
Or tomorrow maybe.
Yeah.
Wednesday.
Oh my god, I can't keep up.
Or non-day off, day off.
Oh, yeah.
No kidding. Okay,
2 hours of distance.
that's energy. We good?
Yeah.
Oh my
Can this
god.
count as my 2 hours of the day?
No.
All
Alright. What's the next framework?
Sleep.
You wish.
Social
Gravitation.
I think it's social.
So, it's the momentum. Now,
I like how we're going over like the entirety of this class in like 2 1.5-hour sessions.
Oh, I thought
Oh, we're only doing 2?
we were, now we're
No,
No, there's more to come.
Okay.
But we'll probably be done with the entire scope
Let's
of
go
this.
up to a little beat.
So how do you calculate the momentum of an object?
MB equals.
I'm getting the most understanding in
Now, if you notice the sheet though, what does it say about the P and the V?
I'm gonna just guess that they're vectors.
Yes,
I can't find
welcome to
it.
the
How'd
party,
you know
man.
that, dude?
Okay?
But,
He just has this
Yes.
instinctual knowledge about what.
That means that the momentum of a single particle is always in the same direction as the velocity. Cool? How do you change the momentum of a particle?
you add mass or add plus?
So that is true. Man, I'm scared to take this bandit off. It's just gonna be a debacle under here. I'm just so nervous. That's why it's all raggedy.
Cub Scout.
Do you think it's gonna get cracked or something?
I think it cut through the nail into the skin.
What was this from?
I tried to come.
Momentum?
Just rip off the nail.
You literally tried to cut your finger.
No.
Mr. Petto, we didn't know you were going backwards.
What is the J?
He was like,
Jewel.
something like a
Jewel.
My name.
Oh, on the bottom where they.
Yeah, up near the
I was
top.
trying to figure out why
What's the J?
Jules.
No.
Impulse.
It's
Oh
the
my
impulse.
I did not know that.
How do you
Throwback.
calculate the impulse?
Simon's like.
Wait, is lowercase j different than uppercase j? Like, are they different, the same kind of thing? Because
We don't have any lowercase j's.
We don't, okay, well, I write
The unit.
impulse is lowercase just because I always confuse it with,
It's not. So, Colin actually made a really smart statement here. I'm not surprised by that. I'm just making sure everyone heard it.
I'm surprised by it.
Actually, shockingly, no. He says, look,
Development.
units and variables can be the same thing, but it's all contextual. This is a variable, not a unit. So capital J for joules is the unit, so you'd have like 853 joules, that's the unit of energy or work. This is something I'm solving for, this is the impulse. Okay? How do you figure out the impulse? Well, to change the momentum of an object, you need to apply a force,
Over a period of time.
but this force needs to last for a period of time.
Oh,
Is
yeah,
that
so
cool?
the change in momentum is impulse, right?
And is that because it's velocity, so it's like meters over seconds, or I don't know?
It's just another way for us to consider something. So
Okay.
I'm going to talk about in a minute the relationship between impulse and work and how they're the same and how they're different. But let's see what we got here. Okay? So it's the force, okay? And this is the change in momentum. Is that cool?
Fantastic.
Luke, can we make a TikTok?
Sure, man, you got an idea?
You know Jane.
Maybe.
Oh, the kid was trying to
Hey,
make
it's 24,000
You caught me.
followers on TikTok.
I want everyone to know
How
this.
much is greater? Don't you like 90? You're 90?
Yeah, 90 probably.
No.
You're almost wrong. He's like,
Oh, you're killing me.
dude, he said like.
Anyway, moving right along.
Mr. Randall's home. How did you guys see this?
Yeah, it's just because this one video where I like fake snored.
Dude, it sounded so good.
Anyway,
was it you?
moving right
No,
along.
it's-
We'll take a brain break in a
Yeah, that's actually
minute,
me.
I promise.
Yeah.
It's hilarious.
I got my
Is those
sister,
actually
I wanted my sister to
brain
record
breaks?
that
Yeah, we're
for
gonna
5
need
days straight.
Oh,
She
okay.
finally-
It was worth it. Did you get
Her TikTok account says she
They
wants
got
to be
it.
more famous than you.
Oh, yeah.
So,
Sorry.
we know that if you want to change the impulse of an, or you want to change the momentum of an object, you have to apply a force. That force needs to last some time. Is that cool? What's the thing about momentum that's really important? That when you look at this,
So sick.
okay, when you look at this, we know that the initial momentum has to be equal to the final momentum. This is as long as,